You have to pay.
If I hear we're getting homework,
Okay. Okay, this section was whether or not this is equal to sine x. So let's start thinking about what we need to do for substitutions here. How about, I think one thing we could do is we could split this up into sine x times sine squared x. Do you see how I took the sine cubed and broke it up? All right. Any thoughts? Does this thing have something we could replace it with? I have a feeling it probably does too, so I better go back to my Pythagorean identity and figure out what it is. Okay, so let's see. If I want cotangent squared x, that would be cosine over sine squared. Okay, so I would divide everything by sine squared. And so I would have cotangent plus 1 equals, what's this thing over here? Cosecant squared x. So we could replace that with cosecant squared x. So far we got sine x, we got sine squared x. Okay, if I were you right now, I think I would focus my attention on that. Remember, the goal is to see if we can get sine x all by itself. So think about what you could replace that cosecant squared with. And don't go back to 1 plus cotangent. That doesn't help you, right? Because that's going backwards. And let's see if there's something else that we could replace cosecant squared with. So talk to your neighbors, State Farm or otherwise, and see what they think. Substitute for cosecant squared. You think we can replace cosecant squared with? 1 over sine squared. Nice. I was told that this could be a replacement. Is this true or not true? That is true, yes. We could replace that, and then of course we got sine squared x and sine x. Okay, are we getting closer? Yes. Now what? Ah, for the win. Sine x is correct. Yes. Okay, so where do you think we should get 1 over sine squared from? So, right here, I don't see 1 over sine squared in it. That equation? We need that one? Well, I needed to know what to replace this with. Now, yeah, if you knew that kind of movement to there, yeah, I could take that. Okay? Folks, the difficulty of this test is that I have to look through all your steps to make sure they're correct. Because a lot of times in these things, okay, so they're asking you to check to see if it's equal to sine x. Let's suppose I just guess. I think it is, right? Now let's see if I can make up a bunch of crap. Let's see if it goes from here to there. Okay, yeah, I do. All right, I look to see if you make steps in the process that are correct. If you don't, you lose. So it's a more time-consuming process to grade these because it's not just, oh, got the right answer. No, I have to look through all the steps. Most of the time, I give you the right answer. I'm trying to see, can you go from here to here? Yes. Yes, Thursday. Thursday is the day. That's why we're reviewing today, reviewing tomorrow.
Is it a two-parter? Is it a two-parter?
It's just one part, front and back of one page.
And then there'll be
a 3-4 test. Then there'll be a retake of either 1, 2, or 3, 4. And on the retake, so we're actually going to cover sections 5 and 6, which are easier than anything else in this whole chapter, and they're on law of cosines and law of sines. And I'm not going to test over those in its own. I'm not going to have a separate test over law of sines and law of cosines. But what I am going to do on everybody's retake is I'll probably have a couple questions from law of sines and law of cosines. So it won't matter if you're retaking the first 1 and 2, or if you're retaking the 3, 4. There'll be a law of sines and law of cosines question thrown in there. So we will have a retake option on this as well. Hopefully you won't need it. Yes? Okay. Whenever you see things like 1 plus cotangent, 1 plus tangent, you should start thinking back to that whole Pythagorean identity, okay, which is what I went back to. So I came down here and I started with the good old Pythagorean identity, and I said to myself, okay, how do I get cotangent out of that? So I saw over here cosine squared, and I said to myself, if I would divide that by sine squared, then I would turn that first term into a cotangent squared. So if I choose to divide that by sine squared, then I would have to divide the next one by sine squared and the last one by sine squared. Well, what is sine squared over sine squared? That's equal to 1, right? So what I'm doing is modifying the original one into its brother or sister, you know? So this one is the cotangent squared of x plus 1 equals cosecant squared x. And yes, as I told you, the Pythagorean identity and its brother and sister are not on your formula sheet. Everything else is. Okay? Okay. Let's go to the next one. Next. Somewhere. Okay, here it is. Prove the identity. Okay, remember. We're going from left to right. Everybody in the room should know what it's going to end up being. And you need to use the right side to give you clues about what to do with the left. I have a question for you. What do you think we should do with those two things, knowing that in the end, all we have are sines and cosines? Yeah, change those two right now into their sine-cosine respective fraction. So obviously one's sine over cosine, one's cosine over sine. Do that substitution right now. Cosine x times sine x over cosine x plus sine x times cosine x over sine x. Okay. Working together as a team. Okay, now keep going. Keep going. Look for things that cancel on. Look for things. Now, I would hold on to that cosine that's in front. I would wait for that for a quick second. A hot minute. I would focus here and see that the signs cancel out there. That might be my first thing. Okay. Now, this is cosine x over 1 now, and we probably need to think about getting common denominators, right? Did you cancel out the sine x's? Did you think to yourself, hey, wait a sec, these things don't have common denominators. Maybe I should do something to this fraction to make it a common denominator with the other one. What would you multiply the top and bottom of that by to get? Wouldn't you multiply by cosine x to the top and the bottom? I know, it's kind of looking messy. So we have cosine x, parentheses, sine x, plus cosine squared x, all over cosine x. Show me the magic. Yes. Beautiful.
Some of the work is cut off in the photos. I'll give you full credit.
Right now.
This is in the top. This is in the bottom. They cancel out. Now I'm done. Now I'm done. I got the answer. I got exactly what they wanted. Yeah.
The outside one.
Okay, anything cancel out? Ah, we got one in the numerator, one in the denominator, and we be done because this equals what they told me it should. We got it. Did I lose anybody? Now would be a good time to ask. I know I got a little sloppy there with the... Okay. All right. So let me answer that question. Let's see. Let me make up a different kind of question here. Okay. 3 times 2 plus 7 over 3. Okay. Now, you and I know we could add the 2 and the 7. We could get 9, right? We could take the 9 and divide by 3 on the inside of the parentheses. We could get 3 and then take 3 times 3 and get back to 9, right? Okay, we could follow the order of operations and do that. Okay, another way to do that would be to rewrite this as 3 over 3 times 2 plus 7 over 1, right? You see how I took the denominator 3 and I slid it over on the outside? So you could see that that cancels out and that you'd end up with 2 plus 7, which is 9. Okay, so if I use that same exact logic here, and I take this thing and I slide it out on the outside, I'd have cosine x over cosine x times sine x plus cosine squared x all over 1. Now we know dividing by 1, you know, it's not going to be earth-shattering. But you're seeing that this out here cancels. Does that kind of help? You're doing something, you got one from the top and one from the bottom. Anytime you have one factor in the top and one factor in the bottom, and I do mean factors, I don't mean addition in between. Kind of helping? Okay. That's a good question. I like it. Anytime you get stuck like that and you're stuck on the algebra, I want to make sure I help explain that. Okay, let's go to 13. I feel some foil coming on, do you? All right, let's foil that thing. Okay, so what is 1 minus tan x times 1 minus tan x? Please do not say 1 minus tan squared x. That would hurt me. Okay, Compare with your friends. See what they get when you FOIL that out. And it would be super cool if you would start with the squared term, then go to the linear term, then go to the constant term. Kind of like we did with polynomials way back when. We could do the box.
That's the only way I can.
Hey, that's fine. It's fine. There's nothing wrong with a box. You know, some people have real hatred towards boxes, you know, which is why they don't work for FedEx. But, you know, and then there's the rest of us. Oops, sorry, that should be a minus. Whew, man, goodness. Seriously, that's why I got it wrong. Because I wrote it wrong? Okay, so we got a 1, we got a tan squared. Ooh, got to have an n in tan. And then a minus tan x and a minus tan x. Man, this is ugly when you're trying to fit it in these little tiny boxes with big fingers. Yep. So hopefully you came up with tangent squared x minus 2 tan x plus 1. Did you get that? All right. Now, look at the answer side. Do you see minus 2 tan x? The answer side. It's right there. I circled it in blue. Okay, well, yeah, if you're colorblind or for the viewers at home, that might be an issue. Okay? So far in our work, do you see a minus 2 tan x? Do you think we should mess with it or leave it alone? Yeah, because we're getting closer to our answer. All right, now let's look at all the stuff that's not in that blue box. What do we have that's outside the blue box? We got tan squared x and what? Plus 1. So the big question I have for you is, what's all this stuff? Trash. Whoa. Trigonometric hatred is not allowed in trig class. Okay, you shall be struck down for that. What? Wait a sec. This kind of feels a little bit Pythagorean identity. Identity? Is that a word? I don't think it is. Oh. Pythagorean identity. Okay, so let's see. Cosine squared x plus sine squared x equals 1. And then if I want tangent squared, that's sine over cosine over cosine over cosine. So there's my tangent squared. There's my plus 1. What's it equal to? Secant squared. Now, I got a quick question for you. Did the answer that you already had kind of give you a clue? Remember, when you're proving an identity, you already know the answer. You are showing me the steps to get there. So the answer kind of gives you some guidance on what you're trying to transform it into, which is why I asked you about the blue box and you said, don't touch it. Now that we got it the way we want it, don't touch the blue box. So then we started looking at all the other stuff that was outside of that to see if we could do substitutions with it. Have I lost anybody here on this stuff? Now would be a good time to yell at. Okay. Okay, I'm going to clear it off if there's no questions on it. Remember, we can record you. Okay, question 15. I bet we should FOIL this. Way.
Foil it. Come on, foil the blue stuff. Think like Reynolds wrap and foil it. Reynolds wrap?
No. Gee whiz, no leftovers in that kid's house.
Oh, that's what that is. Okay.
Yeah, aluminum foil.
Yeah.
Yeah, the shiny stuff, right?
Yeah. I just call it shiny stuff. Yeah. I don't really.
Oh, yeah, it's because all his is gold.
Yeah, definitely.
Okay, when you foiled that together, what'd you get? Well, so 1 time. Oh, you wanted negative cosine squared? We could do that. That's fine. Negative cosine squared u plus 1. Now, just to kind of warn you, most people wouldn't write it like that, and I'll show you why. Because more people would recognize it like this. That's a famous one, isn't it? What is 1 minus cosine squared? That's really sine squared, isn't it? So, you might not recognize it like this one at the top. You might recognize that as sine squared. Now what? Oh, we're done? Yes, ta-da, we're done. We got it. Some of these are quick. Some of them are not as quick. Some of them are a little bit more tricky than others. Okay, go to 17. I'm interested to know what you're going to replace this with.
Yeah, I heard you and you're right, but I need to find out if the rest of them will figure that out. Okay, go back to your book. Do me a favor, somewhere have the Pythagorean identity written down somewhere. All right, write it down. Cosine squared equals 1. We'll use x. Cosine squared x plus sine squared x equals 1. Have it written down somewhere? Cosine. Okay. I want you to take that Pythagorean identity on your paper, and I want you to solve it for this. I want you to rearrange the equation so that on one side of the equal sign, you have cosine squared minus 1. And I want to know what's on the other side. So take your equation, your cosine squared x plus sine squared x equals 1. And I want you to manipulate it so that you get cosine squared x minus 1 on one side of the equation. So where's your Pythagorean identity? Okay, so you're right here. So I want you to get cosine squared x minus 1 on one side. That means everything else. Okay, so I want you to somewhere to write down the see this one. Cosine squared x plus sine squared x. And I want you to manipulate it so that you get cosine squared x minus 1 on the other side of the equation. So I want cosine squared x minus 1. So that obviously means to rearrange the other side. Subtract the 1. Subtract the sine. Oh, you're close. You're very close. It is negative, right? That sine squared over the other side.
Okay, so I'm going to see if you moved your Pythagorean theorem around correctly. Okay. If I want cosine squared x minus 1, obviously that means the 1 is going to have to come over to that side, right? What am I going to do with the sine squared x? Move it to the other side. So I will have cosine squared x minus 1 equals negative sine squared x. So when you do the substitution, it has to be negative sine squared x, not positive sine squared x. Okay? What are you going to do now? Break it apart. Thank you for saying that. Why did I break it apart like that? Okay. The answer gave me a clue, didn't it? First of all, I needed a secant in my answer. I wanted the negative to be with the tangent, and the sine x to be alone by itself. Yeah, I know they're being multiplied together. So that's why I broke it up like this. Right here is my tangent x. It's got a negative. Sine x is by itself. We're just manipulating it till we get it into the form we need it in for the end of the proof. And then we're done for that one. Please tell me when we get to the test that you have more than just the ones I've done with you. It bothers me when I see that you put, some of you put, you only put effort in when you're sitting here. That's a problem. What do you think we should do here? What are we doing with this stuff? Foil? All right, let's do it. Yeah, you can do x's if you don't like beta. That's the Greek letter beta. You're not a beta man? Okay. You can use alpha too. I don't really care. It's just a letter. So when we multiply these together, what do we end up getting? 1 minus sine beta plus cosecant beta minus sine beta cosecant beta. Okay, all we're doing is foiling. First, outsides, insides, last. Same thing you did when you were in Algebra 1. Just not with trig functions. See the part that I circled in red? Can you tell me what's so special about the part that I circled in red? It doesn't equal 1. Nice try. So they're not being multiplied together. So the part in red, I want to know what's so special about that. Say it. You see it? Right here. Negative sine beta plus cosecant beta. They just have it reversed, but that's the answer right there. So what do you think is going to happen with that 1 and this crap over here? It's going to cancel. We have a clue as to what's going to happen in our answer. We just have to find the way to get there. What can we substitute for cosecant beta? Okay, do it. Show me what else you do.
I would be with you there. Somebody told me today that he hopes this really goes and hopes just to see what happens. You see that all of that stuff on my board? You see all my stuff? Yes, if that happens, it's over.
At least for 1 year. I can't do it. Can't do it. Okay. I would even ignore a Super Bowl win if we made it. You know, I'd be like, be a little asterisk next to it. Does not exist.
Just like the asterisk?
Yes, exactly. All right, so what did you say happened right here? What is that? Tell me what that equals. -1, right? Your sine betas cancel, but that still leaves me with -1. So we have 1 minus 1 minus sine beta plus cosecant beta. And the only reason I lumped these together is so that I could cancel them out and be done with the question, right? So we had clues along the way to help us understand what was going on. Any questions about that one? $21. Okay. Do you think we have to FOIL? Do you think we have to FOIL on question 21 on the left side of this equal sign? I don't see any other way, folks. You got something squared plus something squared. There's definitely going to be a bunch of FOIL. Okay? So FOIL the first part, FOIL the second part. Let's see what happens. I mean, there's bound to be some stuff that disappears, right? Yeah, we know that it equals 2, so we know there's a whole lot of stuff that's going to be canceling out here. So, FOIL the first one, FOIL the second one, see if we agree. If this is a lot, maybe we rethink that whole college thing. Yeah, there's no mercy. You're right.
Or wait for somebody else to do what you can I don't know there, right? I don't know the whole thing. If you're struggling with it, then write it out side by side. This is only the first one, folks. I didn't even get to the second one yet. All right. So what do you get when you take cosine times cosine?
Cosine squared.
Cosine squared. How about the outsides? So that's, you could say negative cosine t sine t. You could say negative sine t cosine t. But guess what? You're getting the same thing in there, right? Oh, that hurt.
Doesn't cancel.
They're both negative. How do they cancel? They don't cancel. They add up. Right? They're both negative. Okay, and then lastly, negative sine t times negative sine t. Okay. Tough. Cosine t plus sine t. Cosine t plus sine t. So, same thing's going on here. Cosine squared t, outsides and insides add up to what? What do the outsides and insides add up to? Positive 2 sine t cosine t. And then lasts? Okay, help me add those two things together. This and this. Let me write it up on the big screen.
Okay. So what do you get in the first part here? 2 cosine squared t. And then what happens in the middle? Gone. Plus 2 sine squared t.
If I were you right now, I'd be looking for a greatest common factor. Okay? Show me what to do with that GCF.
Come on, there's a lot of work going on here.
Yeah. That's what I mean. This was the Oh. Yeah, this is the yeah. This is 2K. Maybe 2 is a weird Pythagorean. Okay. What can I see? The GCF.
So we kind of rock.
I'll try to find that, during our lunch. So, when you saw the GCF, what did you do with it? You pulled it out, leaving you cosine squared t plus sine squared t. At this point, you should be really happy. Why? Because this thing is the Pythagorean identity. It equals 1. 2 times 1 is 2. We be done with that proof. Okay? We knew it was going to equal 2. But you got to pay attention to where that Pythagorean identity is going to show up. Okay? So it's going to be everywhere. Or some version of it happens a lot. Okay, 23. We are never done. 1 plus tan squared x. Do we know anything that we could replace that with? We could go sine squared x over cosine squared x. We could do that. But if I go back to my Pythagorean identity, no, not quite. Isn't there one that says 1 plus tan squared x equals something? Isn't it secant squared x? So couldn't I just replace this with secant squared x? What do you see on the bottom? Aren't we done? Woo, that was an easy one. I like that one. That one is called a gift-wrapped problem, all right? They handed that to you, right? I mean, the Pythagorean identity. Yes, just like that, the whole test.